power transmission networks, how do you detect faults before they trigger outages? How do you inspect thousands of towers spread across remote terrain without missing critical issues? And how do you reduce the cost, time, and safety risks of manual inspections? Computer vision solves these challenges by turning drone-captured images into automated insights. From detecting damaged insulators to identifying loose fittings, CV models can analyze every frame with consistent accuracy. Here, you can see a quick inference result. The model identifies insulators on the Powerline structure and highlights them in real time, demonstrating how AI can assist field teams instantly. In this video, you will also learn how to train your own Powerline inspection model. From labeling datasets to using modern object detection architectures, I will walk you through the entire training workflow. If you enjoy our content and want to see more, don't forget to hit subscribe. If you'd like to explore practical resources and hands-on examples, we've created a dedicated GitHub repository. It's filled with cookbooks covering computer vision, AI agents, and more. Link is in description.
Hello everyone, welcome back to this tutorial. In this tutorial, I am going to show you how we can create a computer vision based solution for Powerline inspection. As you know, Powerline inspection is a very manual process and using computer vision will make it more easy. So now see how you can do that. First of all, you need to have a data set. As you can see, I have created a data set of some images like that. Now, with that image, you can train your own computer vision model. So first of all, you have to annotate your dataset on the class which you want to detect in inspection process. So you just have to go to labeler, create the class you want to inspect your power line. I have created an insulator. These are some insulator. You have to create bounding box around that. With that, it will be helps you in training your computer vision model. Now when all the insulator has been marked, you just have to you just have to crop it. You just have to save it. Now all the insulator have been marked. Here is one. Now you just have to submit it. And get to next annotation for annotation process. Now after the process is done, you just have to export your annotation in COCO-JSON file. I have done that for a data set. So with that, it will look something like that. You will have your annotation.json. It will store your annotation file. You can find it using annotations. Here is the bounding box you have created for each image. It will help in model training. Now in next process, you just have to now the annotation file you have JSON has you gotten, you have to start your COCO annotation to YOLO format conversion. You can use this Git repo I have created to convert your COCO JSON to YOLO format. So you just have to import it. I have already done it. It will look like that. From that, you have to import a function called COCO-to-YOLO converter. From that, you can use your function with the value of your annotation part and the image directory. So with that, you will create your YOLO data set. Here you can see there is the test data, train, and validation, and there is our data.yml file. It will help you to train your YOLO model. So with this class insulator at 0, now just start your process by clearing your GPU memory, then start training your model. Training your model in computer vision is very easy using YOLO. You just have to import YOLO, then in YOLO you have to mention the model which you are going to use. Here I am going to use YOLO 11x.pt and then start your training with model.train and the part of data equals to dataset.yml and with the epochs of 150, image size 640, batch 4 device 0 for GPU workers 2. Now run this. I have run that, and it will give you a train folder. In that train folder, you will get your two models, best.pt and last.pt, on your fine tune data. So with that, you just have to load that data for testing. I have loading that model using model part and with YOLO function. Now let's test a sample inference. The sample inference, as you can see, looks good. As you can see, it's detecting all the insulator in the power line. Now let's see another. So it's the same. With that, you can do that. If you train your data on very large data set, it will make your data more accurate and have a better detection in uh, diverse environment. So I will tell you to train your data on large data, but annotation is the important part. You have to make your annotation part very clear, good, so the model you train will be of a good result. So with that, you can now know how you can train your model on Powerline inspection. You can also check our YouTube video on other topics like how to fine-tune YOLO for custom data, like how you can build a system, real-time intrusion detection system with YOLO, or how you can find speed in using YOLO or in computer vision. So with that, we will see you in our next tutorial.